There we go. All right, so now everything is started and broadcast and shared and all that. Oh no, you guys have essays to turn in tomorrow? Oh, today. Essays to turn in today. Oh, wonderful. Like math class starts and we have essays due. Isn't that great? Yeah. Yeah, well, hopefully this math shouldn't be too difficult. Like I said, I wanted to make sure we didn't take too long of a break, for one. Number two, I will be gone the week of February 13th, so I will probably, I don't know if I have anybody that can sub and take over the class that week, so we'll kind of have to come up with a plan for that week. So kind of plan for an easier week in there coming up in a few weeks. And chapter 6 is like 6 sections that are all kind of on their own and perfect for a little, before we get to back to co-op section. So not difficult. Okay, not difficult compared to some other things that we've done in the past. How's that, Elijah? All right, so who do I have here today? I have Mackenzie, Greta, Elijah, Daniel, and one. I don't know who you are. Daniel, I don't think there's a whole lot of graphing in this section. Just kind of some interesting little things in here. We will use our calculator. There is a little bit of graphing at the end. Easy graphing, though. All right, so should we go ahead and get started so that you guys can continue on your day? Hey, Ruben. All right, so prepare your brains. That's all right. I know you guys were going to harass me. I haven't actually taught math in a while, so I've got to get back to explaining math too. Okay, so let me get my whiteboard on here. Hopefully you guys all have your chapter 6 notes. If not, obviously it's on my screen. I did send it out in an email, so that should be available to you guys out there. So we're going to actually start off talking about roots, square roots, and other kinds of roots. So what I mean by that is, hopefully my pen will work this time. This little sign that, come on, you can do it. See, my computer's like, I don't even want to do this stuff. See if I can get it to work here. Come on, computer. I'm trying to draw on the screen and it doesn't even want to let me do that. So come on, pen. No, all right, I think I'm going to have to move this over to paint here. Paint never fails me. There we go. All right, so we're going to talk about square roots and nth roots and what that all means. So the first thing I want to review is what is just the basic, like what is a square root? So the square root is written, seriously, technology today. Square root is written like this. And I think we even talked about this before break, and I know you guys have talked about this before in your other math classes. So for example, if we wanted to take the square root of 25, what we're doing is we're saying, okay, what multiplied by itself gives us 25? So the square root of 25 is 5, right? Or we could say that 5 squared is 25, so that we know that the square root of 5 squared is 5. All right, so this is vaguely familiar. You guys have seen square roots before, kind of remember that idea, right? Everybody's still there. All right, so it's in your brain somewhere, right? So what they didn't teach you, even though you're saying the words and you really don't think about it, is that when you are doing this square root, and you're even saying square root, you've got that word square in there, what you're doing is you're actually, if there's an implied 2 in your root, because you're taking the squared root of a number. Okay, so they don't actually, whenever you take the square root, it's kind of an implied that there's a 2 right there, because you're taking the square root. But we can also take higher level roots of numbers as well. So what I mean by that is you can take the square root of a number. You can also take the cube root of a number. So the cube root of 8. You can take the fourth root of a number, 16. You can take the 100th root of a number if you really want to. Okay, so that's just one concept. I don't know if you've seen that before or not, but when we talk about square roots, we say the word square root, we really don't think about it, but we're implying that we're taking the root of the number. So we want to know what number squared gives us our base number. The only implied number is 2, yeah. And it's weird, right, Elijah? Because we say square root, but we don't really think, oh, square relates to this whole idea of the number squared gives us the squared root. At least a lot of times, I think that when you learn square roots, you don't really think, oh, it's just the square of that. So if you kind of jump around a little bit, if we switch over to like Desmos is somewhere, or your graphing calculator, and you go to take a square root of a number, if it'll load. Nothing wants to work today, right? So if you go to take the square root, it's going to be an implied, square root of 64. It's what number squared gives me 64. Okay, but there also is, if we go under our, if I can hide that. What's it under here? Maybe functions. Yeah, here we go. So under miscellaneous, you'll see that there's a square root with a little n in there. So we can not only take square roots, we can take, third roots, fourth roots. We can also take higher level roots. So what you do here, so the implied is squared. So we'll just show you that. So the square root of 64 should be 8. Okay, but what if we took the third root of 64, and that would be 4. So what? You guys are cracking me up. So what this is telling me is when I take the third root of 64, okay, means that 4 to the third power is 64. So if I do that on here, 4 to the third power is 64. So you can kind of see the relationship, right? Okay, let me read Elijah's comment. The number where the implied number is multiplying the product of the square root. Not multiplying, it's the power. It's going to the power of the square root. I don't know if I'm saying that right. So Elijah, let me show you another example. The third root of 64 is 4. So that means 4 to the third power is 64. So another example would be if I take the fourth root of 81 is 3. Okay, so then if it's basically undoing, right? So then if I take 3 to the fourth power, then I get 81. So that's kind of the relationship to each other. The relationship works the same way the square root does. It's just kind of an extra level on top of what we already know about square roots. That's all right, Elijah. We're all trying to get back. Yep. It's all good. Okay, so that is the nth root. So you can evaluate any level of root at any level there. The other kind of weirdish thing Daniel is already asking about the homework. I'll have to look at the homework. Remind me at the end, Daniel. The other weirdish thing that you may or may not know that is actually kind of cool is that when we talk about the square root of a number, there's another way to write the square root. So let's just go back to our plain old square root that we learned a long time ago, right? So you take the square root of, let's see, 49, right? The square root of 49. If I don't have any number there, you're just assuming it's the square root with the 2. The square root of 49 is the same as 7, right? That's evaluated. So in other words, 7 squared equals 49. Okay. One of the things that's implied with square roots, or another way that you can write square roots, is actually written right here at the top of your notes. So the square root of a can also be written as a to the 1/2 power. Okay, so what I mean by that is the square root of 49, if you ever see a number 49 to the 1/2 power, that is equivalent to the square root of 49. These two are the same expressions. They're just written in different ways. So sometimes I know there's some of you that love fractions. But if you see a fraction on top of a number like that and you're like, what is going on? It's another way to write the square root, to write 1/2. Okay, so let me kind of show you in detail why that works. Let me erase this off here. Have you guys ever seen square root written like that before? I'll tell you why. The fraction. I'll tell you why some of them you can't use a calculator. You'll see. All right, so let's take this square root of 49, this first one right here. Okay, so we said that another way you could write this, 49 can be written as 7 squared, right? So basically the square root, this square root sign and the squared sign cancel each other out and you're left over with 7, right? And then I said, okay, another way to write it is to the 1/2 power. So if I have 49 to the 1/2 power, I could also write that as 7 squared to the 1/2 power. You guys following along so far? Kinda? Okay. And if you remember our exponent rules, when you have an exponent raised to another exponent, you multiply the two exponents together. So 2 times, so this is 7 to the 2 times 1/2 power. And 2 times 1/2 is just 1, so 7, or 7 to the 1 power. Your brain's all starting to be like, okay, I sort of remember this. Is it in there somewhere? This idea of a fraction is new. Okay, so then anything that's written in a fractional form can be evaluated in the same way as a root. So what do I mean by that? It's not that complicated, right? I feel like I need a new screen. It's too messy. All right, so what if I have, let me find a nice, So one of the problems that I have on your sheet is what is the fourth root of 81? Okay, so you could obviously use your graphing calculator or Desmos to calculate this, but let's think about some other ways that we could write this just so that you're familiar with them. Okay, so another way to write 81, the fourth root of 81, is you could write it as 81 to the 1/4 power. That's a good question, Elijah. He said, can you have like a mixed number in your exponent? You could. Your book would probably simplify it beyond that, and we're actually going to talk about how to simplify fraction exponents. Yay. So your book would probably have a little bit of a prettier answer than that. But it might be possible that you end up with that. All right, so let's get back to this. So the fourth root of 81, right? We could write it as 81 to the 1/4 power. And what we want to do is we want to figure out, okay, can we rewrite 81 as something to the fourth power and then undo it with the 1/4, the nth root, the fourth root of that? So I happen to know that 3 to the fourth power is 81. Okay, so you can type that in your calculator. 3 to the fourth power is 81. Okay, so that means if I have 3 to the fourth power, to get my exponent, I multiply 4 times 1/4, and I'm left over with 3 to the first power, or just 3. Yes, exactly, Elijah. That's what we're trying to do. As long as the root's denominator and the exponent match, then you undo the exponent and the root, and you're home free, right? You figured it out. Okay, so there's a little bit more in presto. Exactly. Just like that. So kind of keep this example in your mind because we're going to talk about the number of roots there are with different solutions. Okay, so I'm going to go back to the notes here. Okay. Does everyone kind of get this idea of the root is related to the fraction? You can write it in either way. You okay with that so far? It's starting to click in there. All right, so now let's go back here. So in the middle of your notes, in the middle of your notes, you guys crack me up. There's this little chart and it says number of roots for a real number B. And there's some N's and B's and all kinds of stuff. And in your book, it's on page 414. It looks a little bit different than that. They actually use A and N. So what we're really talking about is when you go to take a root of the number, whether it's the square root, the cube root, the 10th root of a number, how many solutions are you going to end up with? So on this particular chart, it has B. In your book, it has A. But A or B, so I'll put B since I have that. B refers to the number that you're taking the root of. Okay. And N refers to the root, the power of the root that you're using. Okay, so what this tells me is that if I have an even root, so if I'm taking the square root of a number, if I'm taking the fourth root of a number, if I'm taking the 100th root of a number, Any of these things are even. You guys remember what odd and even mean, right? Okay. If you're taking this an even root and the number that you're taking the root of is positive, so it's greater than 0, you're actually going to have two real roots. One is going to be the principal root. So what do I mean by that? Let's take the easiest case. No, it's not an implied number. Okay, let's take the easiest case. N is even, so we're just going to go square root, right? Square root, and I don't even have to write the 2 there. The square root of a number that's greater than 0. Yeah, it's okay, Elijah. There's only one case. The square root of 100. Yes. Let's watch our stuff on the chat, our language and all that. Okay, the square root of 100. This one's easy, right? What's 100? How will we find the square root of 100? Anybody? 10, right? Can't just keep guessing numbers. Who's good with 10? All right, so we want to take the square root of 100. We can think of this as, we could write this as, instead of 100, we can write it as 10 squared, right? Or the square root of 10 squared is just 10. Yes? You guys got to remember that in there somewhere. All right. Technically, this is correct. But this is what we would call the principal root is 10. That's what we would think of. Technically, it could also have a root of negative 10. And why is that? Because negative 10 squared is also 100. So we could also, inside of here, have a negative 10 and a possible square root of 100 could be negative 10. This is also something probably new. I mean, this is what we call the principal root or the, I'm trying to look here. Yeah, this is the one that we principally do. I mean, I think if you type it into your calculator, you're just going to get the positive number. You're not going to get the negative version. But I think you guys all know, oh, if I take the square root of a negative number, I'm going to get a positive. If I took something to the 4th power, right? 10 to the 4th or negative 10 to the 4th power, I'm going to get a positive number. So that's why there's actually 2 solutions when you take the square root. I think we talked about that before. Okay, everybody okay with that? I'm throwing lots of information at you. Your brains are starting to work again, right? What happens if we have an even square root again? So let's switch. We have an even square root, but the number inside the square root is less than 0. Okay, so what if I have the square root of negative 100? You're going to like this one, Elijah, because before we learned, well, we can't do that, right? Technically, this is 10i plus or minus 10i, right? Because when we take the negative square root of a number, we can't do that. That puts us into the imaginary number realm, right? And so we've come up with I. Well, for this particular section, we're just going to say that there's no real roots. Okay? I don't want you to completely forget about I. It still exists. But if you want to look for a real root of a number, it's not real. We have to go to the imaginary numbers to be able to calculate that, right? And then the last case, if you have an even square root, what if it's 0? So the square root of 0. Have you ever tried to do that? Well, in this section, yeah, you don't have to deal with the I. Does that make you guys happy? So the square root of 0 is just 0. Yep. So then when we go to the odd roots, so I've got a mess going on over here. These actually work a little bit easier because when you're dealing with an even root, like 2 or 4 or 100, you have that problem of, oh, when I multiply something an even number of times, a negative can become a positive. When you're dealing with odd, it's easy peasy. There's only one real root for everything. So the third root of 8, that's a positive integer, right? The third root of 8 is just going to be 2. The third root of a negative is also going to be, positive 2. And the third root of 0 is going to be 0. So why is this one positive? Any guesses? So I just covered that really fast. So when you have a third root or in any odd root, so this could be 5, it could be, 7, whatever it is, and you have a negative number inside of here, you don't even know where we are. All right, we're on this little chart here. And we're talking about the number of roots that you can have for different situations. Okay, so we're talking if you have an odd root, so we're taking the third root of all these numbers. If you take the third root of 8, that's a positive number. The only possible solution is 2, because 2 times 2 to the third power is 8. You cannot do negative 2 to the third power because negative 2 to the third power is negative 8, and that's not a solution. So there's only one root, one solution. Okay? My page is going crazy here. Second case, what if we have an odd root, okay, 3, and we have a negative inside of here? Automatically, you might be like, yeah, purple marker. I didn't get any purple markers for Christmas. I want to go buy some. Okay, this one's actually the interesting one. Okay, this blue one that's all crazily written on your screen. So the cube root or the third root of negative 8, you might look at that and say, no way, Mrs. Ross told me there's a negative inside of that root and I can't do it. It has to be I. Done. Well, that's actually kind of interesting because that's the case when you're talking about an even number in here, but when you come to an odd number, we have the whole idea of multiplying odd numbers working together. So actually, negative 2 to the third power is going to give you negative 8. So it is possible to take the cube root or the fifth root or the seventh root of a negative number, where it's not possible to take the square root of a negative number. Well, I don't know what it did for you, but it's just interesting. And then the last case is if you take the cube root of 0, you're just going to get 0. I'm just giving you all this cool information about everything you ever wanted to know about roots is what I should title today. All right, now that I messed up my screen again, one last thing I'm going to tell you. Okay. And then we'll do some examples. All right, so it has to do this. The notes are not that great this time. I apologize. So it has to do with this little a to the m divided by n right here. So I'm talking about this little section right here. So these are two little, what do they call them? Key concepts that you kind of want to keep in the back of your mind. So we just spent a lot of time talking about roots and what they mean, right? I think everybody's okay if I said, okay, I have a to the 1 over n power. That's the same as n, the nth root of a. You guys all right with that? So in real numbers instead of a's and n's, if I have a to the 1/3 power, that's the same as the third root of a. All right, a to the 1/2, it's the same as the square root of a. You okay with that? So to build upon that, what if instead of a to the 1 over n power, I have a to the m over n power? Can all collectively groan. Ugh. Why add another variable, right? It's actually not all that bad because you're going to use the same concept as a to the 1 over n power. So we could rewrite this as nth root of a raised to the power of m. So why is that? Well, we can rewrite our exponents. So if you're really good at exponent rules, this will make sense to you. So you could rewrite a to the m over n power as a to the m, right? Hold on a second. I just lost my train of thought. You can rewrite this as what? A division problem. I'm having like a mind blank right here. I was going somewhere with it. Why am I having a mind blank with this? Somebody that's good with exponents at this moment, tell me what I'm doing here. Oh, yeah. Okay. Sorry, my brain was taking a little vacation. All right, we can write a over of m to the n as a to the m times 1 over n, which you could also write it as a to the m, it's the 1 over n. And then when you do that, you're going to get back to here. Sorry, somebody came and asked me a question and my brain just lost it there. All right, anyway, if you see a fraction that doesn't look like 1 over n, instead it's 3 over 2, you can still evaluate your exponent expression using these rules. I don't feel like I explained that very well, but if it comes back to me a better way to explain that, I will come back to that concept, probably as we do these examples here. Okay, who's ready to do some examples? Yeah, I just lost my train of thought there for a second. Sorry about that. I'll just blame it on break, right? There's a lot of examples here. All right, so let's do some of these examples before my brain totally shuts down. It's like, you've talked enough today. All right, so the first few examples, they actually give you an N and an A, which remember it could be A or B. And these kind of match up to, yeah, 15 and through 19 in your work, which we're actually not even doing. I didn't even assign those problems. So we'll do these really quickly. So what happens if N is 3 and A is negative 216? So what does N and A even mean? We didn't really cover that. So that's why I said these notes aren't very good today. So N refers to the root and A refers to what you're taking the root of. So what I mean by that is we have the third root of negative 216. Okay. So how would I evaluate this? Well, first off, there's a negative in there. Does that mean that there's just no answer and I can give up? The answer is 0. 0 is the answer to everything. Unfortunately, it does not, because we have an odd root, right? Yeah, right, Daniel, we have an odd root. So an odd root means that we could possibly, or we can have one solution to this because of the idea of odds. So I will be completely honest, I don't know what the all of the cubed roots are out that far. I didn't memorize those, but I do happen to know that let me write this over here. I know 6 to the third power is 216. So negative 6 to the third power would be negative 216. So I could evaluate this as negative 6. Okay, and this makes sense because negative 6 cubed, or negative 6 times negative 6 times negative 6 is going to give me negative 6 times negative 6 is positive 36 times a negative 6, and that's going to give me negative 216. What you need? Oh, you're just listening? Yeah. Everybody kind of following along? Have you seen this before? It's new, but not too bad. I need to know what A stands for. I know. A is like the B in your notes. I stole that little chart from somewhere else. So A and B and N. N is the root. A is what is inside the root, or B is what's inside the root. Okay. So what about number 2? The root is, we're taking the fourth root of 81. Okay. I know that you all can plug this into Desmos and figure it out. But what is the fourth root of 81? It's going to be what number? So just to review, another way to write this, we could write this as 81 to the 1/4 power, right? What number to the 4th power gives me 81? 3 to the 4th power gives me 81. So if I want to evaluate the 4th root of 81, I could say that that is 3. But wait, there's more, right? Because I have an even number root, and what I'm taking the root of is positive, it could be positive 3 or negative 3. Because negative 3, also, negative 3 to the 4th power is also 81. Okay? All right. Or it could be negative because one answer would be easy. Yeah. That would be nice, wouldn't it, James? All right. I'm making a mess of all the pages today. All right, so what about number 3? We've got 25 to the 3 over 2. So 3 halves power. I was just reading Elijah. I'm not sure. I don't know if you did it for no reason. Learning is a good reason, right, Elijah? All right. So we've got, I did not mean to do that. 25 to the 3 over 2. 3 halves power. How in the world do we do that? Close, Elijah. It seems like you would do that, right? But what you want to realize is that we are going to actually use this rule that's right above here that I can't get my cursor to go up. So the rule actually says if I have a to the mn power, that's the same as a to the 1 over n m power, which is the same as the square root or the nth root of a to the m power. That's what I was trying to do before, not very elegantly, when I was trying to explain how you would do this. If you have a to the m over n power, you can rewrite it as a to the 1 over nth power to the m power, because when you evaluate this, you get back to here because you multiply the exponents, right? And another way to write a to the 1 over nth power is the nth root of a. So let's just say I kind of, well, let's use this rule here because it's going to help our lives out, right? So what this means is that basically my m is 3 and my n is 2. So you could actually do this without a calculator, okay? Even though it looks crazy. So 25 to the 3 over 2 power, my numerator is 3 and my denominator is 2. So 2 is going to be what root I take. So the second root of 25, so that's where my n goes, right? Raised to the third power. So who knows what the square root of 25 is? Square root of 25 is just 5, right? So the inside of my parentheses is 5 raised to the third power. 5 times 5 times 5 is 125. So see, you could have done that without a calculator. It's in your brains there somewhere, right? Oh, look at number 4. Who thinks they can do number 4 based off of what we just did for number 3? What's the cube root of negative 125? I'm just confused. Weren't we supposed to multiply the squared number by the implied as well? Good question, Elijah. It actually gets back to our good old friend PEMDAS, right? So, or please excuse my dear Aunt Sally. So in PEMDAS, the first 2 letters are please excuse. So we have to do our parentheses before our exponents. So that's why we did what was inside the parentheses before we did the cubed power. Yep. PEMDAS keeps coming back, right? So what about number 4 here. We have the cube root of negative 125. Who says can't do it because it's negative? Anybody? I hope not. Because we have a cubed root, right? And it's an odd number that we're taking, where our root is an odd root. And we know right here that 5 cubed is 125. So negative 5 cubed would give us negative 125. So the cube root of negative 125 is negative 5. Okay. We were supposed to get 5 from the square root, but weren't we supposed to multiply by 2 and then cube? All right, so back here, Elijah's asking me about this one. So this is the one where we had 25 to the 3 over 2, right? 3 halves power. We're going to rewrite it as, we're going to use this, I don't have it up here. We're going to use this expression of, oh, it just scrolled up for me. 2 square root 25 to the 3rd power. We're going to use this way to rewrite our problem, okay? So would we return with 25 and then cube? No. So what we want to do, Elijah, is we've got 25, right? So we're going to do the second root of 25 to the 3rd power. So the second root of 25, or the square root of 25, is just our standard old school square root, right? Square root of 25 is just going to be 5 when I do what's inside the parentheses. Okay. And then once I have my 5 cubed, I have to keep my cubed, and I'm going to get 125. Just confused me earlier. Oh, yeah, I was just kind of, when I was doing that earlier, sorry that I was doing that. I was trying to just reinforce the relationship between what a square root is and squaring the number, or what a cube root is and cubing the number. You don't actually have to multiply back up. Yeah, sorry. Okay, so we have just a few more examples left here, and we had a lot of fun learning about all these, crazy kind of roots that we take. Wasn't this fun so far? Is that one word to describe it? What can we actually do with this information? That's what these last 4 problems are. We don't even have to necessarily do all these 4 problems. So this is the last little part of your homework, 51 through 57 odd. So what happens if I do have, for example, x cubed equals 64, and I want to solve for x? That's right, Daniel. So how do I actually solve this? I don't know if you remember I know that we've done this at some point. I can't tell you what section. And I feel like that we've done it in algebra as well. So at some point you may have done this. At some point you may have forgotten that you can do this. But just like we can add and subtract, just like when we want to solve for x in other equations, we can add, subtract, multiply, divide. We can square both sides of an equation. We can take the square root of both sides of the equation. I think we just talked about this last section, right? Exactly, Daniel. So we can actually take the cube root of both sides. So instead of this being x squared, and we take the square root, we're going to take the cube root, right? So we're going to say the cube root of x cubed, And then if I do this to the left side, I also have to take the cube root of the right side. Okay, so x cubed, cube root, just leaves me with x. And the cube root of 64 is 4. And this makes sense, right? If I plug 4 in up here, 4 cubed, 4 times 4 is 8, 8 times 4 is 64. So you can actually use them to do something, right? What about number 6? We have 1/2 x to the 5th equals 512. So this kind of requires a little bit of thinking. I want to solve for x, right? Because that's kind of the point of algebra. Learn all this other stuff, but we're eventually solving for x, right? But before I just go and take the 5th root of both sides of the equation, you want to move 1/2 to the other side of the equation. So we're going to do that by multiplying both sides by 2. Okay, because you don't want to have to deal with taking the 5th root of 1/2. Okay, so if I'm left over with x to the 5th equals 1024. Now I can take the 5th root of both sides, and I end up with x equals 4. Again, x equals 4. Okay. Any questions about those? I feel like it's like all the hard stuff at the beginning, and then you get to this and you're like, oh, I can do that. Especially if you can use a calculator to help you figure out what the 5th root of 1024 is, right? 7 is 3x squared equals 108. So do I just want to go straight and take the square root? No, I want to get rid of the 3 first, right? We'll talk about the homework, Mr. Daniel. Divide by 3. X squared equals 36. This one should be easy peasy, right? So if x squared equals 36, I just need to take the square root of both sides. What does x equal? It's kind of a quick trick question, actually. All right, pay attention to this one, and then I'll tell you what you got to do in your homework. So the square root of 36 is 6, right? But because we're taking the positive, this is a positive and an even number, it could also be -6. Right? So x could be plus or minus 6 for this particular equation. Yep. Let me just show you. I know we have like 3 minutes left, but let me show you super fast. Remember that 3x squared equals 180. 3x squared equals 180. No, I just said that wrong. 108. Let me just show you what this looks like when you graph it. So if I have 3x squared, no, cube, 3x squared, and I have y equals 108. I'm going to need to zoom out, obviously. Do you like the graphing or not? Not, I couldn't tell the sarcasm over the chat, so I don't know. Maybe you like it. Does all the work for you. There we go. So where do these two meet? They meet when x equals 6 and when x equals -6. So that's why you have, when we did all that work and you're like, why do I have 2 roots for this particular one? It's because they don't meet there. Yeah, they do. So we have the black graph is 3x squared. Okay, so these are all the values of 3x squared. When x equals 0, it equals 0. On the other side of the equation we want to know when 3x squared equals 108. So this is 108, right? They do intersect if we zoom in here, Elijah. So what this is saying, when x equals 6, both sides of the equation equal 108. 108, yeah. I just think it's kind of cool to tie it all together that, oh, okay. That's why there is two roots, two possible solutions to this equation. Versus if I have 3x instead of 3x squared, if I have 3x cubed, the graph of 3x cubed looks a lot different than 3x squared, right? It's this squiggly funny line thing. And there's only going to be one possible solution where they meet. If I change this to another even number, so to the 6th power, we're going to have two solutions again. So if I just confused you on that and that didn't help you out, sorry. But I just think that sometimes it's helpful to see the visual too. Like I'm telling you there's two roots when it's, an even number and it's a positive number. But to actually see it sometimes, I don't know, for me that kind of helps out. All right, so now to the Elijah and Daniel homework that they're harassing me about my use calculator, not use calculator. I am actually okay with you using a calculator on any of these problems. However, my goal is not for you to sit there and plug everything in the calculator. Yes, I will instate a rule that allows you to find cute. So I am completely fine even if you're doing the easy numbers. So number 3 is 2 to the 1/3 power. You really don't need to plug that into your calculator to figure out what it matches up to. My goal for this section is for you to kind of understand what you're doing. Now, am I expecting you to remember the fourth, powers of, 8 to the 4th power is whatever, and remember that? No, not necessarily. But I don't want you just sitting there and plugging everything in Desmos and not kind of doing any of the work behind it. So if you're doing something like, for example, number 25, which is 27 to the 2/3 power, I don't want you to just plug 27 to the 2/3 power in Desmos and tell me what it is. I want you to show me that, oh, okay, I'm going to take the cube root of 27 and then I'm going to square that. So I want to see a little bit of work behind it. Yeah, I'm going to leave it. You guys are high school students, so I will leave it to your discretion. But obviously my goal isn't for you to sit there for hours to figure out what the, discretion. Yeah. My goal isn't for you to figure out what, anything above 512 is. My goal is for you to understand what you're doing when you actually have, an exponent that has a fraction in it. So I don't want to just get your homework and see all the numbers listed down. There should be some work that goes behind it. Does that make sense? Yep, like usual. So I don't know why. I think for an older class, I don't know why I have that spelled out, use calculator, don't use calculator. You can use your calculator for any of them if you're stuck, but I do want to see that you kind of understand it. Oh, it's 12:02. I kept you 2 minutes late. Just like normal, right? Just like at co-op. Okay. That is all that I was going to cover today. I actually was going to do a little 6-2, but apparently I talked a little bit too long. So we might not quite get through all of chapter 6 over the break. We'll just see. We'll play it by ear. I may send something out. I might even just record something for you guys to watch. Or we can do Friday. I don't know how people's schedule are you going to do. Yes, Daniel, I am going on vacation in February, somewhere warm. I will miss you all. So what do you guys think? Would you rather do 6-2 on Friday, like in a live class, or would you rather have me just record something that you can watch when you're ready? All right, Daniel, I will think about you. I'll say, huh, I would be in class right now. So I will be thinking about you guys. I guess miss is a little strong, huh? I'll miss all your smiling faces. All right, so 6-2. 6-2 is actually, not to keep you guys too much longer. 6-2 is actually everything. This chart should look really familiar because this is what we did in 5. I forget the section, 5-3, 5-2, something like that. But now that we know, so we're going to review these properties again, which you should know because we've done them a lot, right? Even though I had a total brain blank for a moment there. But before, when we used all these properties of exponents, we had whole numbers, right? And now we're going to have fractions. So that's all there is to 6-2, honestly. So would you like me to do that on Friday? Do you want me to record something you can watch on your own time? What works better for people? I don't know how your schedules are over break. Recording better? I have 1 vote for recording something. You guys can just watch when you're ready. Does that work for you guys? I know that this section was more complex, but really that's all 6-2 is here's the properties again, and here's what you do when they're a fraction. All right. I will send out a recording in the next day or 2, and then you can watch that when you're ready, when your brains are ready, and then we'll talk next Monday. Oh, and my battery of my computer is done too. Watch me live stream it. All right. You guys are cracking me up. It was good to talk to you guys. Hopefully this worked out being on the call. If anything's confusing to you or you need anything explained again, please let me know. I know my brain is coming back from break too, so I am happy to help. That's it, guys. See y'all soon. Have a good week. At least it's supposed to warm up. So yes, till next week. Bye. Bye, Greta. Bye, James, Mackenzie, Daniel, Elijah.